moisture in the atmosphere. Atmospheric moisture comes from two places: evaporation and transpiration, plants giving off water. Sort of think of it as plant sweat. Humidity. There's two measurements of humidity, which is the amount of moisture in the air. Absolute is the actual mass of water in the air, whereas relative humidity is how saturated or how full the air is of moisture. If the air is 100%, then water won't evaporate. The air is already filled with all of the moisture it can hold. So imagine at 10 degrees, it can't hold much moisture. So a little bit of moisture will give you 100% relative humidity. When the temperature increases a bit, hotter air can actually hold more moisture. So the same amount of water vapor is only 52% relative humidity. You make it even hotter, and now the humidity has dropped further. The warmer it is, the more moisture it can hold, and so the more the relative humidity will decrease. The drier the air will feel. Now, how do we measure humidity? Well, we use this odd device called a sling psychrometer. That's it here on the right. You hold this tube in your hand, and then it's got this hanging out, and you twirl it around. Kind of looks like you're playing with a party favor. Inside here are two thermometers, what we call the dry bulb and the wet bulb. The dry bulb is a plain old normal thermometer. The wet bulb is a normal thermometer wearing a wet sock. Very odd, I know. Basically, the idea is this. If it's hot outside, how does your body cool off? You sweat, right? Moisture comes to the surface of your skin, and then, if the air is dry enough, the water evaporates. When water evaporates from your skin, it takes with it a good deal of heat, thus cooling you off. So when water evaporates, it drops the temperature. So as you're slinging this thermometer around, the water evaporates. The more it evaporates, the more this temperature drops. But, have you ever heard somebody complain it's not the heat, it's the humidity? I'm sure you have. What it means is if the air is very, very humid, then the air is already filled with all the moisture it can hold. It won't hold anymore. So the sweat on your body, or the moisture on this wet sock, won't evaporate. So your temperature doesn't drop. The sweat won't evaporate, you'll still be hot, and now you'll be sticky too. So you look at the comparison between your dry bulb and wet bulb temperature. So the sling psychrometer has two thermometers. The wet bulb will be lower due to evaporative cooling, meaning the water evaporates, thus lowering the temperature, just as sweat lowers your temperature. If there's a bigger difference in temperature between the wet and the dry bulb, then that means a lot of the moisture evaporated and we have a low humidity. It's dry. But if the temperature didn't change much, if it didn't cool off, then the air must already be very moist and humid. We calculate it using this chart. This chart is in your textbook. On the left, you have the dry bulb temperature, and across the top, you have the difference between wet and dry bulb. We're going to pretend that our dry bulb temperature was 14 degrees Celsius. So here it is. We know our humidity must be one of these. And if our wet bulb is 9 degrees, we need the difference. 14 minus 9 is 5. So the difference between wet and dry bulb is 5. And we see where this hits the 14, and we know we have a 50% relative humidity. The air is half filled with moisture. But let's say the temperature were still 14, but the wet bulb were 13. 14 minus 13 is 1. So our difference is only 1, and that gives us a humidity of 89%. That is too humid to want to be outside much. It's going to be very sticky. The air is almost filled with water, so it's not going to hold anymore. So you're going to feel a lot stickier if you go out. Dew point is another temperature we like to discuss in weather. It's the point or temperature at which water will condense. If you ever look at a can of soda that somebody has left out, you can tell immediately if it's fresh out of the fridge or not, because it may have water on the surface of it. Now, the water didn't come from inside the can. The water is condensed from the atmosphere. The can was cold, so the water in the atmosphere cooled off and condensed on the surface of the can, giving you dew. That's the same way the dew forms on your car and the grass in the morning. The air cooled off during the night, the water condensed, and produced the dew. The point, the temperature at which this happens, is the dew point. And we can calculate dew point as well using this chart, exactly the same as relative humidity. Again, if our dry bulb were 14, and our wet bulb were 9, 14 minus 9 is a difference of 5, which means our dew point is 4 degrees. Dew point is 4 degrees. So if the temperature that's now 14, if it cooled off to 4 degrees in the night, we'd have dew. Now if the temperature were 14 and the wet bulb were 13, again that gives us a difference of 1, so our dew point is 12 degrees. If the temperature drops from 14 to 12 in the night, dew will form. That's what this means. So condensation happens when the air cools below the dew point, and this produces dew or cloud droplets. When warm, wet air from the surface rises up, it cools at a very predictable rate, actually, and when it hits the dew point, finally rises high enough that the temperature has dropped to the dew point, condensation forms on condensation nuclei, little particles of dust in the air, and we get clouds. This is why if you take a look at clouds sometime soon, the bottom of the cloud would usually be flat, because below it the temperature is above the dew point, and above it the temperature is at or below the dew point. So it's produced clouds. The condensation level, you also hear about it in planes, is the ceiling, is the height at which these clouds form. This is some relative scale. Here's a bit of dust in the air. It can be like dust from some sand, from volcanoes, from smoke, from forest fires, ocean salt. Any small particle of dust, you have to have that for water to condense. Water can't condense on itself. It needs an object to condense around. So a cloud droplet can form on top of the dust. If the air is too clean, actually, you won't get any rain. No clouds will form. So this is a cloud droplet, and this is what a raindrop looks like. Kind of neat. So clouds are actually liquid water droplets. You think of them as a gas, they are not. They are liquid water or solid water, ice crystals. Because you can't see gas. You can only see liquids and solids. Cloud is what we call it when the liquid water droplets or the ice crystals are popular. There's enough of them that they can be visible. Haze is when they aren't quite visible. You know how sometimes in the summertime it's not a blue sky, it's kind of a white blue? That's the haze. There's enough moisture in the air that there is water condensing, but it's not quite enough to call it a cloud yet. Fog is a cloud at the Earth's surface. The condensation levels at Earth's surface, we've got 100% humidity, and we've got all sorts of moisture right around us. So clouds form where the air temperature and the dew point are the same. The atmospheric transparency is how much light can pass through the air. If there's more particles in the air, it's less transparent. Smog, sort of a mix of smoke and fog. It's basically a haze that's got a lot of pollution in it. Fortunately, precipitation tends to clean the air pollutants because the water condenses on the pollutants, like the pollutant acts as a condensation nuclei. So the water condenses on the dust or pollutant, and then ultimately rains it out, brings it back down to the surface of the earth, which is part of why after a summer storm or a rainstorm, the air smells much cleaner. This is what smog looks like. If you drive, for instance, on 395 towards DC, you will see the smog sitting over the city from all of the car exhaust. The car exhaust is actually adding to the pollution in the air, and water is condensing on that, and that's what produces the yellowish or green or brown fog. Precipitation happens when those cloud droplets get heavy enough, there's enough water condensed on them that they fall. Different types. You've got rain, snow, sleet, freezing rain, and hail. Rain and snow, you know. Sleet are raindrops that refroze. Freezing rain is rain that freezes onto the surface. Hail happens not during the winter. Usually it happens with a really nasty thunderstorm. In a thunderstorm, the winds are powerful enough that they hold up the ice crystals long enough that they get extra layers of ice built up on them and become heavier rocks. To see how this happens, you've got snow. For snow, it has to have, here we've got temperature, and here's 32 degrees Fahrenheit, freezing point. Above freezing, below freezing. For snow, the temperature has to be below freezing the entire way down from the cloud. If it gets above freezing, these delicate little ice crystals will melt. The only way you get snow is if it stays cold the whole way down. Part of why we don't get as much snow as we'd like. Here we have sleet. It was snow up in the atmosphere, but it got a little warmer partway down, and it melted. But then it was cold down here a bit too. Perhaps this is a cloud that's trapping some heat. And so it refroze into tiny little droplets. If you've ever seen these really tiny pellets of ice bouncing off your windowsill, that's sleet. They're frozen raindrops. Freezing rain is a little further. It was ice crystals, then it melted, and it melted the whole way down. But the Earth's surface itself was cold. Perhaps it's been cold for many days or something. And so after the rain hits the surface, it freezes onto the surface. And that's what makes the pretty but deadly ice-covered branches or ice-covered roads. We measure precipitation in two ways. This is a rain gauge. It's basically a tube, a cup, and it measures how much liquid precipitation you get. And you use a measuring stick for frozen precipitation. So, precipitation requires moist rising air to form clouds. If the air doesn't have moisture, you don't get clouds or precipitation. If the air isn't rising, it doesn't cool below the dew point, so you don't get clouds. As we discussed last time, on Earth, it tends to be wet at the equator and at 60 degrees north and south, and then dry at 30 degrees north and south and at the poles. We also get precipitation due to the rain shadow, or the orographic effect. Orographic means mountain. Again, as wind hits the mountain, it's forced up, it rises, cools, dumps its moisture, and on the leeward side it sinks, warms, and has no moisture. So that's how clouds form, and rain.